Zulu Papa 5, Whiskey Bravo Mike from Mike's and Bravo Alpha Alpha.
It's a whole different quality.
It all totally depends on temperature and moisture. How you move.
We got a dog now. I took over Kelly's ball. Pretty much over here now with a noise level. But excellent copies.
So, we don't need the instructions for the next bit because it's really simple. So all we need to do now is go sudo apt install GQRX-SDR. That's a bit more like it. Press Y to continue. And we're also going to install a package that will improve the performance of a specific computer. It's possible to tune the performance between the computer and the software. So this is on GQRX.dk, these instructions. I just Google GQRX and it's the first thing that comes up. So we will be installing this, and this will do a little bit of customization. Okay, that's almost finished. And now we're going to install this libvulk bin package. And there's a 2 version. Okay, try that. And it's already installed. So if we type in vulk profile, making sure we've got an underscore in, and this is going to do a little bit of testing, and this will align the performance. Okay, so that performance tuning took about 20 minutes, which is a lot longer than I expected. So we can now run our GQRX program, which we can do from the command line, or from the start menu. So the first thing it's going to do is configure the program. And I need to select one of these. I don't know why it's come up twice, that's strange. Okay, so inevitably it didn't find the SDR in the configuration list. Reason being, we needed to reboot the computer. So if I go into the configuration now, it's now listed. So there were 2 generic ones at the top. It wasn't that. Mine is this one, Realtek RTL 2838 UHIDR. So that's the one I needed to select. And bingo, we've now got a working radio. So we need to start it. So when you need to stop it before you change the configuration, and then you need to start it. Don't know the exact frequency I want, but if you click the mouse on a digit, okay, we're getting to copyright problems. Music on. You can see that you can tune across the radio spectrum. So that's broadcast FM radio. So this is obviously the frequency, and it goes all the way up to gigahertz. This shows you the relative signal strength, or should I say the absolute signal strength, because all of this lot is variable. So this is showing the radio spectrum, and this is what we're tuned into. So at the moment it's 90.7 megahertz. We've got a number of filters we can apply. So you can have narrow or custom or wide filtering. We can also make the filter normal, soft or sharp according to our needs. We then have different modulation modes. So wideband FM, show you. wideband FM is the normal one for broadcast FM. But there's also two noise blankers. These tend to work best for repetitive pulses rather than actual hiss type noise. The other modulation modes we've got, we can turn it off because sometimes you just want to send the raw signal into some other software. There's the raw IQ mode, and that requires a lot more explanation, to be honest with you, but it sends out two signals, one which is I, which is inverted, and Q, which isn't inverted. And again, these two signals can be used into other hardware or software decoding. Not something I'll be doing. AM, and the reason that we want AM is because many frequencies are coded in AM or amplitude modulation. The modulation AM has nothing to do with the actual frequency it's on. Any frequency can be modulated with any type of modulation. So people talk about the FM band, which is 88 to 108 megahertz in the UK. It's not the FM band, it's a specific frequency band. And there used to be AM radio transmissions on it as well for private radio. Narrow FM, which is what most handheld walkie-talkies or voice-only radio uses. Remarkably, the entire aviation system works on AM. And that's what I've actually tuned into at the moment, but obviously the local airport's not doing much. And then the automatic gain control, I rarely need to move it from that, basically because I have it turned off. Normally you find that works better turned down. So that's the initial, the low noise amplifier at the front end. This is the first thing that the aerial goes into. And if you have it set too high, it can distort. And then there's various controls that we can use to improve the performance. So that's the input controls. Then there's the radio controls. You can run an offset. It's very handy if you rapidly want to change the Abbott radio guys, and what they call duplex radio transmissions actually work on one transmit frequency and one receive frequency, and they're 600 kilohertz apart. So you can very rapidly type in with the keyboard 600 kilohertz, and that's now, I'm pointing at the screen as if you can see it. That's now offset that by 600, and the frequency we wanted is over here now. Don't forget to set it back to 0 afterwards, otherwise you'll be chasing your tail and recording wrong frequencies. The squelch control we've talked about, again you can vary this manually. You can press A, sometimes you need to press it twice to get it to work, and if you want to turn it off you can press R for reset, and that just opens the squelch so you can hear whatever is going on. Okay? That's the basics of that. Now then, you'll notice this display is all yellow and not very clear. We can now go into FFT settings. Now, I think I'm right in saying that FFT stands for Fast Fourier Transform. This is the way that software is able to tune frequencies and set bandwidths on a radio. It's something you might want to look into, more than likely you won't. Just accept it. According to the size of the transform, that affects the quality of the signal that is being decoded. It's also something you can tune. If you've got very fast or very slow PC, you may need to tune that. So this display is updating at 25 frames a second at the moment. There are different types of decoding. Just leave it on what it's set at until you learn a lot more about radio. Now, we have two sections to the display. The first one is the pan display at the top, and we can adjust the gain and offset on this to suit any particular set of signal levels. And although that's clipping there, it's not doing any harm to the signal, it's just the way it's displayed. And you can make it really sensitive, but sometimes you find that strong signals will then cause that to roll off. We can then do the same thing with the waterfall display. And at the moment, there's not a lot happening. But when signals are coming and going, notably on the airband, some of these signals will start coming and going. We can now tune this, and according to how we set it up, Generally, no signal should be dark blue. Some people prefer it to be completely black, some like it to be dark blue. And it's personal preference, but set it to how you like it. You can either have it completely black here to show no signal, but it's possible you might miss some of the weaker signals. So sometimes just have it into the blue maybe. And the stronger signals going into the red. It's fiddly to operate with the mouse, as you can tell. There we go. So these stronger signals here, these are minus 30 decibels, which is a really strong signal. And again, sometimes it's better to turn the gain down and bring everything down. And you can set these to what you want. Sometimes there's an advantage, if you're listening to handheld walkie-talkies and trying to discover new frequencies, sometimes there's a big advantage to slowing this down, this waterfall, because at the moment it's taking about 8 seconds to fall off the bottom of the screen. As always, when you try and demonstrate something to people, it's inevitably you can't find a signal. I'm just getting the frequencies off my other computer. And we could sit here for quite a while, and it's quite annoying. Oh, there's one. So what you can do now is you can drop your mouse down to where that frequency is, 134175. So 134175. And if that comes up again, we should hear it.
Lake Transit, Nottingham 2000 feet, CFR, QNH 1023, Golf Romeo, November.
How convenient was that? And that is Nottingham Airport for the aviators among you, which is a couple of miles from my house. In fact, it's less than a couple of miles because I walk past it regularly. So that's Nottingham Airport, and you can see there's another weak signal here. It's very tempting to try and tune into these strong ones, but generally you'll find you need other decoders for them. So just to recap, we're in the air band, which starts at 119 megahertz up to 138 or 139 megahertz. I'll provide links to these frequencies, so to lists where you can find the frequencies for your local airports, because I think it's one of the best introductions to learning about how radio. There he is again. So that's working well at the moment. You notice there's quite a lot of hiss in that, so sometimes it's better to put a filter on, and we'll put a narrow filter on that. And it's great being able to tune these frequencies, but how the heck are we going to remember them? So if we press Control Shift and B, we can create a set of bookmarks. So that's Nottingham Airport. You can name them anything you like. So we can create a tag. So that's the bookmark name. And then we can set and call this air. And then when we set that, there's Nottingham Airport. And if we can see our bookmarks by pressing Control B, Nottingham Airport's down here, and it's in the air channel frequency band. So you can have untagged, you can store stuff untagged until you've established what it is. So you might want to separate out marine frequencies, amateur radio, broadcast, walkie-talkies, whatever. There's all sorts of things you can set up. And in a minute I'm going to import a frequency list into here just to show you what happens. So that's our Nottingham Airport. So let's have a look at this frequency here. So it's about 134,280. And again, you know, we can just go to 880. So that's something we're not going to be able to decode. And you can just click on this frequency and it'll jump to it immediately. There's another guy here, 134875. That's easy because you can just, you know. There's a bit of a trick to being able to do this on a keyboard. Just checking my frequency list. And this is the other Nottingham Airport frequency. And inevitably one will be the tower. Airports usually have several frequencies. There'll be the tower, the conning tower, There'll be one for the ground staff, there'll be the incoming aircraft, and sometimes they're on the same frequency and sometimes they're not. You know, it's as simple as that. You can get listings. There are a lot of listings. Getting up-to-date listings is a little bit trickier. So you need to experiment. If you've found somebody on a frequency, Google it or use any search engine of your choice and look for what's in your area. A typical, for instance, is I can pick up the frequency 1338, and this is quite an interesting frequency where I live because it's Scottish air control, and that's quite a long way from where I live in Nottingham. And you wonder why you can pick it up when I'm struggling to pick up East Midlands Airport 10-15 miles away. And the answer is, it's also the handover from Manchester Airport to Scotland. And obviously airplanes would have difficulty picking that up from this distance. So they've actually installed a repeater in Grantham in Lincolnshire, about 15 miles from where I live. And I can pick that up, and it's not the best reception, but I'm using an indoor aerial in a building with very thick walls. The walls in this house are so thick that we struggle to get Wi-Fi through them, and we've literally had to put Ethernet cable all over the place to get internet up in the rafters here. So yeah, it's frequencies are not always what they sound like. If you look at these closely, you'll see that's not actually a straight line. That's 133. That's 4418. It decides to come up again. And you develop a knack of being able to do this really quickly, where you just find this line. One thing that you will notice with SDRs is you get phantom frequencies, and you'll see a frequency come up and you'll tune to it, and then the next time you transmit, it'll be a few hundred kilohertz away. One of the slight problems with SDR is it was never designed for radio. It was designed for digital video broadcasting or digital television. It was actually designed to make budget mobile television receivers for caravans and narrowboats and things. And the internal clock runs at 28.2 megahertz. Consequently, anything that's a multiple of 28.2 megahertz can generate phantom frequencies. It's worse at the bottom end of the band. So that's just a very brief look at airband. You can go on the aviation YouTube channels. You'll find a lot more information out. Just a quick talk about the frequencies that we can receive. This goes from 26 megahertz all the way up to 1.7 gigahertz. Now, at these frequency extremes, the gain rolls off. It's not as sensitive. And the other thing is you're going to need different aerials. The little whip aerial I've got here is mainly for airband, 2 metre amateur band and 70 centimetre amateur band and UHF walkie-talkies and PMR. I'll go into all these in a lot more depth on the blog. The astute among you will notice that that's near the old CB frequency, which is 2695. And I've tuned around this quite a few times, and it's very rare that you pick anything up. If we go at 27, you can pretty much see the whole CB frequency because it starts at 26965. Actually, what I'm saying isn't strictly true because there's two different sets of frequencies. But they're very close to 26965 to 27405. So that is the whole 40 channel AM CB band. And the FM band and other modulation band is slightly different. I used to play with CB radio back in the day in the 80s. And at the age of about 13, I used to play with amateur radio receivers or shortwave receivers, listening to amateur radio and radio all over the world. The internet has taken a lot of that away from us. People are less dependent on radio now than they were then. There's still a lot of other interesting things you can do with SDR, and we'll look at more of those later. As you can see, the CB frequency is completely dead. I have got a longer aerial which would work a lot better. So I might plug that in and have a look. But that's the introduction, that's GQRX working. Next we're going to have a look at some other demodulation techniques. And one of those is ADS-B, which the aviation fans will know is a frequency that transmits data from passing aircraft, and you can decode it very simply and you can learn a lot about aviation. If you are impatient, you can go to flightradar24.com and they get that data from all over the country, and you can see every commercial airplane that's in the sky, and quite a few light aircraft as well, but you can't see military ones for obvious reasons. That would be bonkers, wouldn't it? But you can certainly see commercial aircraft, and I'll do a screenshot of that before, when we do the ADS-B. So that's what we'll have a look at next, and we'll see you in a minute.
Yeah, we are in the place to be. Yeah.